Hello students, this video is about the 7th lesson in Unit 3. It's about parallel line proofs. Now that you have all the information about different types of parallel line relationships, all the different angle relationships created when two parallel lines are cut by a transversal, you can move on to starting to write proofs. Just like we started to do in Unit 2, we're able to write a proof, a formal geometric proof that lays down all of our statements and the reasons for those statements. This is a very favorite topic amongst students, so hopefully you will enjoy this a lot. The learning target is I can apply parallel and perpendicular angle relationships. I can tell you that most of these are going to be parallel angle relationships, or sometimes known as transversal relationships, in diagrams to compose two-column proofs. Remember, those two-column proofs consist of statements and reasons. All right, this is just a refresher from the Unit 2 lesson on proofs. It asks us to prove that angle X plus angle W plus angle Z is equal to 180, and that normally sounds like a pretty easy feat because of the triangle sum theorem, but you can see that angle X is here, angle W is actually up here, and angle Z is down here, so it doesn't really fit the triangle sum theorem. But there's a way around it using the relationship between these two angles. Pause the video and try to write this one out, and then see if you got it right. All right, like I tell students all the time when we start writing proofs, a proof is written sort of like in an essay format where it doesn't really matter most of the time, or some of the time I should say, it doesn't really matter what order you put your statements in as long as they form a logical progression, right? If you're writing an essay, it doesn't matter what sentence you write first or what sentence you write second, always, as long as you get your point across. In this case, there are a couple of different things that I could do first. The thing I chose to do first was identify that angle W and angle Y are equal to each other. They're congruent to each other, actually. So to be more mathematically accurate, I said that the measure of angle W is equal to the measure of angle Y. Whatever these two numbers are, they're equal to each other. And the reason I said that is because of vertical angles. I know that vertical angles are congruent to each other. In other words, they have the same measurement. That next step that I can identify is that angle X plus angle Y plus angle Z is equal to 180. I know that because I can see that those three angles are the interior angles of a triangle. They form that triangle, which means they all add up to, or they sum to, 180 degrees. Next, what I need to do is make X plus W plus Z equal to 180, which means I'm going to take this angle Y here and replace it with something that's equivalent to angle Y, which is angle W. That's with substitution. So you can see I wrote out that equation right here, replacing that angle Y with that angle W. And the reason I can tell that we are done with this problem is because this sentence, the thing that they asked us to prove, matches exactly with the statement that I made here. Once I have this proof matches this last statement, I am done with the proof. Fantastic. Moving on to the types of problems that you might see in the practice here, there are two different scenarios that you might be placed in. The first scenario is they tell you that there are parallel lines in the problem. In this case, they tell us that QS is parallel to TV. They could have told us also by giving those little arrows. If you use these little arrows, that indicates that those two lines run alongside each other and never intersect. In other words, they have the same slope. In other words, they're parallel. So if they give you parallel lines, you are able to use any of the transversal relationships that you know to identify missing angles. For example, the transversal relationships include all sorts of different things. They include alternate interior, alternate exterior, consecutive exterior, and also corresponding. So once I know that those two lines are parallel, I'm able to use whichever one of those relationships I want in order to help me prove this part, which is PRQ is congruent to VUW. I know that those two angles are PRQ here and VUW out here, and I know that when two angles are on opposite sides of the transversal and they're outside the two parallel lines, that means they are alternate exterior angles. So the first thing I can write is QS is parallel to TV, which is given. And then I can say, well, those two angles must be congruent because of alternate exterior angles. It's a piece of information that I'm allowed to use because I know that the two lines are parallel. However, you don't always know that the two lines are parallel. As a matter of fact, sometimes they'll give you a scenario in which they're asking you to prove parallel lines. So for example, in this case, it gives you two measurements of the two different angles, and it says, now I want you to prove that the two lines are parallel. So remember, the information that is given to you is information that you already know to be true. The information that is in the prove part is not something that you know already. It's something that you have to prove. You don't know it for a fact. So you can't use any transversal relationships until the very end of the proof. Here's an example. In this problem, it tells us that MNP is 130 degrees. That's the one that's out here. And it tells us that the measure of JKI is 50 degrees. That's the one over here. Those two angles aren't necessarily angles that are connected to each other. And it also tells us to prove that OM is parallel to JL. There's a lot of different ways to answer this question, but I chose to answer it like this. I know that MNP is equal to 130. That's given to me. That's a piece of information that's up here. And JKI is 50 degrees. That's also given to me. I was able to use supplementary angles. You know, supplementary angles are angles that form a straight line. To say that JKN, which is over here, I'll use another arc here to represent the fact that this is different. JKN is 130 degrees as well, because 130 plus 50 is 180. So now I know that this angle is 130, and this angle is also 130. Guess what? If these two angles are the same measurement, that means that we can start using transversal relationships. I know that these two angles are considered corresponding angles. So since they are equal to each other, I can say that they're corresponding angles, which means that OM is parallel to JL. They wouldn't be equal to each other unless the two lines were parallel. So two different ways to go about it, or two different problems that they might give you. If they give you the fact that it's parallel lines, you can use whatever relationships that you want of the transversal relationships. If they do not give you that the two lines are parallel already in the problem, then you can't use the transversal relationships until the very end of the problem. Hopefully that gets across to you. I'm going to give you two model examples. If you want, pause the video now and try to write this problem out on a piece of paper, and then come back to see if you get it right. Now, the first thing I like to do in a problem is start labeling it. It tells us that MQ is a line, which just tells us that from M to Q is straight. It doesn't have any bends in it. It tells us that angle 1 is congruent to angle 3, which means this angle here is congruent to this angle here. And it also tells us that segment PR bisects, which means cuts in half, angle QPN. All right, so the thing that it wants us to prove is that MN is parallel to PR. Here's MN, and I like to sometimes extend the lines a little bit so I can see a little bit better. And here's PR. Okay, it definitely looks like these lines could potentially be parallel to each other. They look like they're running alongside each other, but we need to use information from the problem in order to figure this out. When it says PR bisects QPN, from Q to P to N is here, which means this angle is exactly the same measurement as this angle. All right, now we're cooking a little bit, because now I know that this angle, 4, is congruent to this angle, 1, which means since they're the same measurement and they're in the same place, they're corresponding, which means I'm going to be able to prove that parallel lines exist. Let's try to take a look at what the proof looks like. All right, let's take it nice and easy. It says that angle 1 is congruent to angle 3, so I wrote that in my statements and I said given. It also says that PR bisects QPN. I wrote that in my statements and I wrote given. The next thing that I wanted to try to identify is the fact that angle 3 and angle 4 are the same as each other. They're the same measurement. I haven't said that yet, so it's important for me to say that next. And I know that they're the same measurement because a bisector cuts an angle into two congruent pieces, each half of the original. All right, this is the definition of a bisector. A bisector cuts an angle into two equal pieces, each half the original. But you're in luck, because I'm about to show you one of the really important tools in our arsenal for proofs. I don't have to write out the exact definition of bisector every single time, because when we write out a proof, we're assuming that the person who's reading the proof knows what a bisector is. So in other words, instead of writing out the definition of a bisector, all I'm going to do is write the words definition of angle bisector. Because you should know that the definition of an angle bisector is an angle's bisector creates two separate angles that are congruent to each other, each half the original. So I don't have to write out the whole thing, which is amazing. I can use this trick for a lot of other things, which I'll show you on later lessons. Our next job is to identify the fact that this angle here and this angle here are congruent. The reason we want to show that those two angles are congruent is because those two angles are actually going to form the basis of my argument that these two lines are parallel. Because if those two angles are congruent to each other, these two angles are called corresponding angles. So what I have to do is say that angle 4 and angle 1 are equal to each other. Their measures are equal. I have 1 here and I have 4 here, and it turns out that they're both equal to the same thing. Now, before we used something called the substitution property, which means I'm able to substitute things into equations, but this is a little bit different because this entire equation is equal to this entire equation. When two equations are both equal to the same exact value, we can put those equations together. That's called the transitive property. And here's a quick rundown of that transitive property. When two expressions are equal to the same value, they're equal to each other. So A is equal to B is equal to C. They're both equal to B, so A and C are the same. That's what the transitive property is. So I'm going to write that transitive property out as my step number 4. Okay, now I'm home free because it asks us to prove that MN and PR are parallel to each other. I know that two parallel lines would have two angles that are in these two positions that are congruent to each other. Turns out that's what we have. These two angles would be considered corresponding angles if these two lines were congruent, and since they are congruent to each other, these two lines must be parallel. So my fifth and last statement is going to be the fact that these two lines are parallel because of corresponding angles. And there you have it. There's our first model example. Remember, in this model example, we were asked to prove that MN is parallel to PR. Notice we didn't say anything about those transversal relationships until the very end. Moving on to the next model example, we have given to us that AB is parallel to CE. Now in this case, we know that AB and CE are parallel to each other, so we're able to use that. We're also supposed to prove that angles 2, 3, and 4 are equal to 180. So let's label what we have on the diagram. It's not a whole lot, I'm afraid. I only know that AB and EC are parallel to each other. So let's start off our statements and reasons by writing that. Now remember, since they told us that these two lines are parallel, we're able to use any of those transversal angle relationships as many times as we want. One thing that I can tell right away, because these two lines are parallel, is that some of the angles are going to be congruent to each other. Most notably, angle 1 is going to be congruent to angle 4, because this transversal cuts these two parallel lines in such a way to make angles 1 and 4 alternate interior angles. I say alternate interior, you look for the shape that looks like a Z. So I'm going to rate that next. The question asks us to prove that these three angles add together to equal 180. And when I think three angles equal 180, I think the triangle sum theorem. I see that angles 1, 2, and 3 add together to give me 180. So I'm going to lead with that, or I'm going to follow, I guess, with that. That's going to be my third statement. And here's one thing that you might have already noticed. I am trying to prove that 2, 3, and 4 are equal to 180. I have 1, 2, 3 are equal to 180, but I also know that 1 can be easily replaced with 4. So that's what I'm going to do next. Since I'm not replacing one entire equation and one entire other equation, I'm just putting one value into this equation. I don't use the transitive property here. I'm going to use substitution. All right. You can tell that this prove statement, the 2 plus 3 plus 4 is equal to 180, we've satisfied it. 2 plus 3 plus 4 is equal to 180. At this point, you could probably end the problem right away and no issues would come up. It is true, however, that these are in the wrong sort of order. So what we generally want to do is make sure that the prove statement matches exactly with our last statement. So I'm just going to rearrange the angle 2, angle 3, and angle 4 in my answer using something called the commutative property. And that commutative property states that I'm able to rearrange different terms that are being added together, and it does not change the value of the actual problem. I don't think that any grader would ever take away points for having the different things you're adding in a different order, but I just wanted to show you a completely correct mathematical procedure because I'm a math teacher. That's my job. All right, this was the video on parallel line proofs. You hopefully learned what to do when they give you information about whether lines are parallel and also when they ask you to prove that lines are parallel. Good luck studying.